Welcome everyone. Today we are solving problem 7.56 from Sadiku book. The problem says for the network find Vt for t is greater than 0. So if we give a focus to this switch, there will be switch is currently on and it will be opened when t equals to 0, t is greater than 0, right? T is greater than 1 actually, or t is greater than 0, right? So switch is currently closed. For this portion, let's just calculate the current through this out. Okay, so current through, we have to calculate current through this inductor, right? We have to calculate current through this inductor. So let's just simply apply nodal analysis using nodal analysis. Okay, using nodal analysis, the switch is closed. So we have one terminal, one node here in the whole circuit. We have one terminal, and it will be replaced as short circuit, right? If we had to really consider this, so the equation will be -2 plus v by 12 plus v by 20 plus v by 6 plus v minus 20 divided by 5 equals to 0. So let's just quick calculate the v. So let's just calculating the v through my calculator. It will be -2v 1 by x by 12 x by 20. So the v voltage through this terminal or this node will be 12 volt. Okay, so current through the inductor I equals to what? I equals to v by 6, right? V by 6. So I 0 minus equals to I0 equals to 12 divided by 6 equals to what? 2 ampere. For now let's calculate this was for t is less than 0. Now calculate this for t is greater than 0. Okay, for t is greater than 0, the switch is opened, right? For t is greater than 0, switch is opened. If the switch is opened, then we have this portion for the circuit. This portion is out of this consideration. So we have this portion. So let's just quickly redraw, and what can we do? We can do source transformation here. So we have to make this as current source, and this 5 ohm it's parallel. So the circuit will be look like something like this. Here we have 20 ohm, and here we have 6 ohm with inductor, and here we have 5 ohm, it's 5 ohm, and a current source which arrow will be in upstairs, and 20 divided by 5 equals to 4 ampere. So now let's just calculate this out. Hold on a second. It will be 20 ohm, it will be 6 ohm. Let's just write this as, now 20 ohm and 5 ohm are in parallel, right? We can just pull this resistance here. So 20 and 5 are in parallel. So the circuit will be something look like this. 4 ohm, 20 and 5 in parallel with equals to 4. In 6 ohm with inductor, and the current source is 4 ampere, right? Okay, so it will be 6 ohm, and the current through is I infinity, right? So let's just calculate I infinity through current divider law. If we use current divider law, I infinity will be 4 by 4 plus 6 into total current 4. So the current will be ultimately 4 by 10 into 4, 16 by 10 equals to 1.6 ampere. So I infinity will be 1.6 ampere. Now let's just quickly calculate tau. Okay, what is the value of tau? Tau equals to, for RL circuit, tau will be equals to L by R, right? Tau equals to L by R. Now if we had to calculate tau will be voltage through these two terminals. We can easily say that for these two terminals, 20, let's just focus in this, 20 and 5 are in parallel, right? 20 and 5 are in parallel, and nope, we calculate this here. 20 and 5 are in parallel, which will be ultimately 4, and in series with 6. So it will be total 10. So R equivalent will be 10, or RTH will be 10. So it will be L by R. The value of L equals to what? The value of L equals to 0.5. 0.5 divided by 10. So it will be 0.05, right? So it will be 0.05. Now calculate this, the equation IT. IT equals to I infinity plus V0 minus V infinity. Sorry, my bad. I0 minus I infinity e to the power minus t by tau, right? Okay, so I infinity equals to what? I infinity equals to 1.6, I0 equals to what? I0 equals to 2. So 1.6 plus it is what? 1.6 minus 2.4 equals to minus plus 0.4, 0.4 e to the power minus t by 0.05. Okay, so this will be the answer for our current, or we can just simply write this as 0.6 plus 0.4 e to the power 1 divided by 0.05. What will be the value? 10, 100, 520. So it will be minus 20t, minus 20t. Okay, minus 20t ampere. Now they just wanted us to calculate Vt. So Vt will be what? For inductor we know Vt equals to what? L di by dt, right? So what is the value of L by inductance? It will be 0.5 into d by dt of this value. D by dt of 1.6 plus 0.4 e to the power minus 20t. So just the answer will be okay, let's just calculate this out. 0.5 into minus 20 into 0.4 e to the power minus 40. So it will be minus 4 e to the power minus 20t volt. This will be the answer for question number 7.56. I hope you guys enjoyed the video. Thank you.